So we're continuing with CSEC Add Math May 2024 Paper 2, and we're on question 1, Part B. So this question is on sum and product of roots. So the equation kx squared plus x minus 15 is equal to 10 has roots alpha and beta, where k is a member of the set of whole numbers. So Part 1, determine expressions for alpha plus beta and alpha beta for 2 marks. Okay, so before we find the sum and product of the roots, we have to get that 10 from the right hand side and move it over to the left hand side. Okay, so kx squared plus x minus 15. And if we subtract 10 from both sides, right, so we end up with the equation kx squared plus x minus 15 minus 10 will be minus 25. So now we can find the sum of the roots. So sum of the roots alpha plus beta is equal to minus b over a. Okay, so according to our quadratic equation, b is 1, so that will be minus 1. And a is k. Okay, so alpha plus beta is negative 1 over k. So let's find alpha beta, this product of our roots, is equal to c over a. And c is negative 25. And a is k. So our product of our roots alpha beta is negative 25 over k. Right, so that's your 2 marks there. So let's go on to part 2. Given that alpha squared plus beta squared is equal to 61 over 4, use the expressions in Part B, Part 1 to determine the value of k. Okay, and this is with 4 marks. Now, alpha squared plus beta squared. Alright, so that looks familiar. So let's recall, and instead of a and b, I'm going to use alpha and beta. So this identity, a plus b squared, or in this case, alpha plus beta squared, we know is equal to a squared, or alpha squared, plus 2ab, or 2 alpha beta, plus b squared, or beta squared. So if I want to make alpha squared plus beta squared the subject, I'll have to subtract the 2 alpha beta. So I'm going to write that across here. Alpha squared plus beta squared then will be equal to alpha plus beta all squared minus 2 alpha beta. Okay, so now we can go ahead and substitute what we have. So we're given that alpha squared plus beta squared is 61 over 4. Now alpha plus beta, of course, is sum of our roots that we got from part 1 is negative 1 over k. So negative 1 over k, and we're squaring that, minus 2 times alpha beta. So 2 times the product of our roots. And the product of our roots was negative 25 over k. Okay, so let's simplify our left-hand side now. So negative 1 over k squared, negative 1 squared is just positive 1. And of course, we have k squared. And minus times a minus, that will actually give us a plus. 2 times 25 will be 50 over k. Alright, so let's make this into one fraction. Alright, so common denominator will be k squared. So this, of course, will be 1. Alright, so k into k squared will be k times 50, so that's 50k. So if I cross multiply like that, I get 61k squared will be equal to 4 times 1, 4. 4 times 50, so that's 200k. Alright, so we get a quadratic. So 61k squared plus, actually minus, because when I move everything over to the left hand side, change signs. So we get a quadratic where we have to solve for k. Alright, so just use the quadratic formula. So k is equal to minus b, so that's minus 200 plus or minus the square root of b squared minus 200 squared minus 4 by a by c. And be careful with the signs, of course, all over 2 by a. Alright, so that's 200 plus or minus. Okay, let's figure out the square root part. So that's 400 plus the minus, and minus give a plus, so that's 4 by 61 by 4. So it's the square root of 1376 divided by 2 by 61 is equal to 122. Okay, so let's plug this in directly into our calculator. So 200 plus the square root of 1376, and then we divide that by 122, so we get 1.94. They didn't tell us how many decimal places, so I'll just use 2. Or 200 minus square root of 1376, and then divide by 122, and we will get positive 1.34. So those are our two values of k.